Good morning, class. This is a quick lesson on how the product rule of exponents works. Okay, the rule goes as follow. All right, when multiplying monomials with the same base, add the exponents. Okay, monomials are one-term polynomials. If you want to know how naming polynomials works, you have to watch the videos that are made on naming polynomials. So this is the rule. So a to the n times a to the m equal a to the n plus m. We just need to add the exponents. So I have 5 examples here, actually 4 examples, and the fifth one are non-examples, right? So let's get started. So uh, first, just using numbers, not variables. 3 square times 3 cube, okay? So using the rule, um, we just need to add, we just need to add 3 plus the exponent, sorry. So that's 3 to the power 2 plus 3. So that gives us 2 to the 3 to the power 5. Okay. But since these are numbers, you could have squared 3, and that would have given you 9. Okay. And you could have cubed 3, and that would have given you 27. 9 times 27 is 243. So, or you could have applying the rule, you could go straight to 3 cube, which is 3 times 3 times 3 times 3, 5 times, which will also give you the same answer. Okay. But this is just meant for you to see how the rule is applied. Okay. So let's go to example number 2. All right. Where you only have variables. Notice we have the same base, right? It's x. The base right here is x, right? Above right here, the base is 3 and 3, right? So because these bases are the same and it's a product, we are multiplying them. We can basically just say it's x to the power 5 plus 7. And 5 plus 7, that's 12. So the answer would be x to the power 12. Okay, we just add 5 and 7, applying the rule. Okay, so example number 3, right? So you have 4x cubed times 2x squared, right? Now notice right here you have numbers that are mixed into the system. So what you are going to do is first take care of multiplying those numbers. So 4 times 2, that's 8. And now you can apply the rule on the variables. So x cubed times x squared is simply x to the power 3. That 3 is coming from here, plus 2. And that 2 is coming from here. Just applying the rule. Okay. So that would give us 8x to the 5th power. Now let's go to example number 4. Okay, notice that parentheses are also another symbol for multiplication, same as the dot, right? So this is 2x to the 5th power y times 5x cubed y square, right? So because it's all multiplication, we can just drop the parentheses, right? So we can just drop the parentheses. So that's 2x to the 5th power y times 5x cube y square. Okay. Since we are going to be applying the rule, okay, let's make sure that we put the exponent on the variable that don't have exponents. For example, y, uh, right here, the exponent is 1. When you don't see an exponent on the variable, the exponent is 1. Remember, anything to the exponent of 0 is 1. So if there is the variable, that means the exponent is 1, right? So as always, let's start with dealing with the uh, numbers first. So 2 times 5, that's 10. Now we can only deal with the variable that have the same basis, right? So x to the 5th power times x cube. So that would be x to the 5th power plus 3. I'm just adding the exponent following the rule. Now I can move to a different base, which is y. So y to the power 1 times y square, okay, would be y to the 1 plus 2. So the next step would be to add the exponent as, so 5 plus 3, that's 8, and 1 plus 2, that's 3. And then I'm done. This is as far as I can go. X, this is base, the base of this is x, and the base of this is y. So we cannot combine these exponents. That's as far as we can go. Now, example 5 is not actually an example, it's a counter-example. Notice that this right here is not a product, this is addition, right? So this is not part of what we call the product rule. The reason why I put this one here is so that you are aware of it, that the product rule of exponent applies only to products, right? Not to addition or subtraction, right? Now, this one right here, 2x to the 5th power plus 4x to the 5th power, we can simplify. These are like terms. We all have 2 of something plus 4 of that same thing. That means that's 6 of that thing, right? When we have like terms have the same variable and same exponent. So x to the 5th power and x to the 5th power are like terms. So we just need to add the coefficients, right? Okay, we have 2 of them here plus 4 of them. That means that's 6 of them in total. Now, for case B, these are not like terms, right? Because they don't, even though the variable are the same, the exponent are not the same. So you cannot do anything with this. This is done as it is. I don't want to make the video longer than this, so I'm going to stop here. And I hope I hope this make it clear enough for you. Have a good day.